Okay. So that's this is the class file, right? The class file has a bytecode. That bytecode will be loaded into JVM. Every computer has its own JVM. Like Windows has its own JVM, Linux has its own JVM, and Mac has its own JVM. So this JVM is different and Windows JVM is different. Again, Linux JVM is different. All are not same. So this class file is common to all the JVMs. Why? It's a bytecode. So the bytecode is common to all the JVMs. That's why Java code can be run on anywhere. You write once and it can be run anywhere. Same file can be run on Mac, on Windows, and Linux. You can run any of these three places or anywhere, anywhere you can run the same file. So that means, so why you are able to run this? So Java has its own software environment, and also the bytecode is common to all the platforms. That's the main reason. So what is the main reason? So Java code can be run on multiple platforms because so Java code is compiled by the compiler and converted into bytecode. That's what I have shown you, right? Java code is compiled by the compiler. What is the compiler name we discussed? Java compiler name? Java C. Java C. So just remember Java compiler. So the shortcut is a Java C, that tool name, and converted into bytecode. So this bytecode is a platform independent code because it can be run on any platforms. It can be run on any platforms or multiple platforms. So you will write once and run anywhere. So you will write once and run anywhere. So that's the, so why Java is a platform independent means you need to answer this. So Java code is converted into bytecode by the compiler, and this bytecode is platform independent because it can be run on multiple platforms. So Java is a secured programming language. So why it is a secured programming language? So as I mentioned, Java, there is no pointer concept in Java. And so if you observe these two diagrams, see C++ application and run on top of the OS only. But whereas Java application runs deep inside OS inside, you have a JVM. JVM inside your Java code will execute. So there are many layers, okay? There's a protection will be there, more protection. That's why, so we can develop virus-free and secure Java applications. And in the JVM, so there is no pointers concept, and the Java programs runs very deep inside the sandbox. And this JVM has many components. So we'll discuss again. Basically it's a abstract machine. That machine inside you have so many components. Class loader is the one component, bytecode verifier, security manager, interpreter, and execution engine inside interpreter will be there. So and libraries will be there. Those are all available in the JVM inside. So what this class loader will do, we generated a class file, right, after compiling. that class files will be loaded into JVM by this class loader. What is the responsibility of class loader? Class loader will load all the class files into JVM. That's a class loader responsibility. So if you see here, so after compilation, you will get this class file, right? These class files loaded into JVM by whom? The JVM component class loader. Class loader will load these class files into JVM. This, once it is loaded, then so it will be verified the bytecode is correct or not by bytecode verifier. So then there is a memories and it will store in the memories also. The memory areas, I will tell that. Then security manager. So each resource is properly accessible or not, you can check. That's a security manager. So these are all the points makes Java very, very strong, and because it runs very deep inside the JVM. OS inside JVM, JVM inside Java application will execute. So there is other way also you can implement this security, like you have SSL, secure socket layer, JAS, so Java objects as a security, cryptography. So all these different concepts also you can use to develop so this secured applications. And now, so Java is a robust programming language. What is mean by robust? It's a strong programming language. So Java has a strong memory management. So its memory is very, very strong. And so you have a lot of memory partitions. So that's a strong memory management. There is a lack of pointers that avoids the security problems. So there is no automatic garbage collection in Java, which runs on the Java virtual machine to get rid of objects which are not being used by Java applications anymore. So that means if you created an object, you're not using that. That means unnecessarily you're using that memory, right? That memory you can so identified by JVM, garbage collector, that will clean up automatically. If it finds you're not using that object anymore, then it will clean up. Automatic garbage collection. In C++, what you need to do is you have to schedule the garbage collection. But here it's not like that. It will keep running frequently it is keep running and going to check. So that's the robust programming language. So there are exception handling concepts and type checking mechanism in Java. All these points make Java very strong. So that's Java is a robust programming language. And it's a architecture neutral. So it's a architecture neutral. And Java is as I mentioned, Java bytecode can be run on any architecture. So it doesn't depend on the, it is a 32-bit or 64-bit, it doesn't matter. Any hardware or software, it will run your program because the bytecode is common to all of them. So portable language. So portability means, right? Carrying so same thing to other platform. Here also Java bytecode you can carry to any other platforms. That's a portable language. So it doesn't require any implementation. So that's a portability. And you can say Java is a independent programming language, architecture neutral, portable language because of the bytecode. Simple one answer for all of them. And it will run on different architectures, same file. High performance languages. Java is faster than any other programming languages. So because Java bytecode is closer to native code. Native code means already existing code. Already Java guys written, right? That code. So it is still a little bit slower than a compiled language, C++. So Java is an interpreted language. That's why it is slower than compiled languages, C and C++. So Java is a distributed programming language. So you can create a distributed applications like RMA and EJB are used to create a distributed applications. Like you can access these Java applications from anywhere. If you have internet or from anywhere you can access. So Java is a multi-threaded applications. So multi-threaded means each thread will act as a separate program and they will execute concurrently. For example, you are accessing same resource, I am accessing same resource, and the different persons are accessing same resource. And for each person, one thread will create and it will serve your purpose. And same resource I can use, and if I access, another thread will create for me. That means same memory will be shared by all threads. It doesn't occupy a memory for each thread. So the main advantage multi-threading is that it doesn't occupy a memory for each thread. It shares a common memory area. So threads are important for multimedia, web applications, anything such kind of places. Multi-threading is a very, very important concept. So it's a dynamic programming language. And whenever you require loading classes into JVM, on the need basis, it will load. So that's all the features of Java. Java is a simple, object-oriented, independent, security, architecture neutral, portable, high performance, robust, distributed, multi-threaded, dynamic programming language. That's a Java features. So what are the difference between, any questions here, Sanjit?
No, good so far.
Okay. So this is the very important, okay? This is very important. So what is JDK, JRE, and JVM? So let's understand JDK and then we'll come back maybe tomorrow JVM. So let's understand JRE and JDK today, and tomorrow I'll explain JVM. So what is JRE? Java Runtime Environment. It is also known as RTE, Java Runtime Environment. So it's a Java Runtime Environment is a set of software tools which are used for developing Java applications, and it is used to provide the runtime environment, and it is the implementation of JVM. It is physically exist, and it contains JVM plus set of library files and other files. So these are called JRE, and see when you have a JRE in your machine, you can run your programs. You don't need a complete Java. If you have JRE, you can run it, your programs in your machine. So if you don't have, you cannot. Then what is JDK? Java Development Kit. So it's an acronym for JDK. And JDK is mainly it's a software development environment. So which is used to develop Java applications and applets, and it physically exists. Basically, JDK means JRE plus development tools. What are the development tools? Java C, Java. So Java C means I already told you, it's a compiler. An archiver jar, an interpreter, Java. So a document generator, Java doc. So all these are tools, development tools. So these tools plus JRE. So both combinedly called JDK. So JDK means JRE plus development tools. Now, so what is happening here is before Java, till Java 8, okay, till Java 8, JRE and JDK, they were showing separately. Okay. After Java 9, so they are only showing JDK. Why they are not showing separately JRE is because already JRE is inbuilt inside the JDK. So they don't want to show that. That's why they changed that and giving only JDK folder when you install Java, Java 11, anything. We're going to install Java 11, okay? Or you can use any latest also, no problem. So that's all about JDK and JRE. And tomorrow we'll see maybe some questions here. You can go through that. What is Java? Who is the father of Java? Who is in green team? Where and all Java is used? What are different type of Java applications? What are different type of Java editions? What is a Java compiler name? Why Java is a platform independent? So what are different tasks performed by Java? I'll tell this tomorrow, okay? I just explained this one. What are the difference between JRE, JDK? And you just go through this, okay? At least a few of them, all these questions. Okay?
Sure.
So we'll see tomorrow.